Hello and welcome to 9.7 Taylor Polynomials and Approximations. Polynomial functions can be used as approximations for other elementary functions. So notice if f of x equals e to the x, if we use a polynomial approximation p of x equals 1 plus x, that's close. It'll give you a nice, it's just a little line, but it gives you a close approximation e of x to e to the x when f of x is around x equals 0. But as x gets further and further away, this will become very inaccurate. Now if we took f of x equals e to the x power, I should say, and p of x equals a plus x plus 1/2 x squared plus 1/3 factorial x cubed, this will be a pretty good approximation for a longer distance of time on the x-axis. So this will better approximate for more values of x. So we can define a means for utilizing this process. Let me scroll this up here. So the definition of the nth Taylor polynomial and the nth Maclaurin polynomial. If f has n derivatives at c, then the polynomial p sub n of x equals f of c plus f prime at c times x minus c plus f double prime at c over 2 factorial times x minus c squared plus dot 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 plus the nth derivative of f at c over n factorial times x minus c to the n. This is called the nth Taylor polynomial for f at c. If c equals 0, then p sub n of x equals f of 0. So this is the case that c is 0. You get f of 0, f prime of 0 at x times x, plus f double prime of 0 over 2 factorial times x squared plus dot dot dot. That means all the stuff in between. That this pattern continues until you have what you define your nth, your last term. The nth derivative of f at 0 over n factorial times x to the n power. This is called the nth Maclaurin polynomial. So the Maclaurin polynomial is the Taylor polynomial where c is 0. So, for example, one says find the first degree polynomial function p1 whose value and slope agree with the value and slope of f at x equals c. So we have f of x equals 4 over the square root of x and c equals 1. So I can rewrite this f of x equals 4x to the negative 1/2 and f of 1 is going to be 4 times 1 to the negative 1/2, which is 4. Now our first derivative, f prime of x, is going to be 4 times negative 1/2 x to the negative 3/2, which is negative 2x to the negative 3/2. So f prime at 1 is going to be negative 2 times 1 to the negative 3/2, which is negative 2. So our p1, our polynomial to 1 degree, is going to be our f of 1 plus f prime of 1 times x minus 1. That's going to be 4, our f of 1 was 4, plus f prime of 1 is negative 2 times x minus 1. So our p1 would be 4 minus 2x plus 2, which is, let's go down here, p1 is 6 minus 2x. Or you could say p1 equals negative 2x plus 6. And that's it. That'd be a 1 degree approximation of this function. So this is a linear approximation, 1 degree linear approximation of this function around 1. I'm going to scroll on this. Go ahead and feel free to pause if you'd like. Clear the board. So example 2 says find the Maclaurin polynomial of degree n for the function. Now, again, Maclaurin, our c equals 0 then. That's what it means to be a Maclaurin. Okay, so our n equals 5. So our initial one, f of x is e to the negative x. F of 0, because our c is 0 here, is e to the negative 0, which is just 0. That's just 1. Our first derivative is going to be negative e to the negative x. So f prime at 0 is going to be e to the negative 0, which is, or sorry, negative e to the negative 0, which is negative 1. Again, I know 0 is not negative or positive, but I'm just kind of filling in the spaces. F double prime of x is going to be positive e to the negative x, so f double prime at 0 is going to be e to the negative 0, which is 1. F triple prime of x is going to be negative e to the negative x. F triple prime at 0 is going to be negative e to the negative 0, which is again negative 1. The fourth derivative, and I'll put a little parentheses there, of x is going to be e to the negative x. The fourth derivative at 0 is negative e to the negative 0, which is negative 1. No, actually this is positive now this time, positive 1. Hope we see a pattern by now. The fifth derivative of f of x is going to be negative e to the negative x. So our fifth derivative at 0 is going to be negative e to the negative 0, which is negative 1. So it alternates 1, negative 1, 1, negative 1, 1, negative 1. So our P5, that's what we're going to go out to 5 here, of x is going to be f of 0 plus f prime of x times x plus f double prime of x times x over 2 factorial, sorry, let me do this, over 2 factorial here times x squared, plus f triple prime of x over 3 factorial times x cubed, plus the fourth derivative of x over 4 factorial x to the fourth plus fifth derivative, I should have said at 0, not at x, over 5 factorial times x to the fifth power. Now, these all should have been zeros, not x's. And we already have found these values. One thing I want to kind of pause on and go back and hit was that n factorial is n times n minus 1 times n minus 2 all the way down to 2 times 1. So 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. So our P5 of x is going to be 1 plus, that was negative 1 times x, plus 1 over 2 times x squared, plus negative 1x cubed times x cubed over 6, plus 1 times x to the fourth over 24, plus negative 1 times x to the fifth over 120. So our P5 of x is going to be 1 minus x plus x squared over 2 minus x cubed over 6 plus x to the fourth over 24 minus x to the fifth over 120. That is the final answer for that problem. Okay, feel free to pause that one. For the next one, my notes, as you see if I scroll on this, that shows 3 and 4 together. So I need to get some extra space for this. So I'm just going to blank this out and do example 3. And example 3 says, approximate the function at the given value of x using the polynomial f of x. No, wrong one. Find the nth Taylor polynomial centered at C. So f of x equals natural log of x, n equals 4, and c equals 1. So, what if I can turn this back on and find a blank spot that I can work with the light on? Let's see what we can do here. Is there any spots that are there? That looks good. So I'll write this over again. Example 3, f of x is natural log of x, n equals 4, c equals 1. Okay, so our f of x is natural log of x. F prime of x is 1 over x. F double prime of x is going to be negative 1 over x squared. F triple prime of x is going to be 2 over x cubed. And the fourth derivative of f of x is going to be negative 6 over x to the fourth. So our f of 0 is going to be natural log, no, f of 1 I should say, not 0. F of 1 is going to be natural log of 1, which is 0. F prime of 1 is going to be 1 over 1, which is 1. F double prime of 1 is going to be negative 1 over 1 squared, which is negative 1. F triple prime of 1 is going to be 2 over 1 cubed, which is 2. And the fourth derivative of f at 1 is negative 6 over 1 to the fourth, which is negative 6. Let's put it all together. Our P4 is going to be our f of 1 plus f prime of 1 times x plus f double prime of 1 times x squared over 2 factorial plus f triple prime of 1 over 3 factorial times x cubed plus the fourth derivative of f at 1 over 4 factorial times x to the fourth. And I should have said x minus 1, not just x, because our c is 1, not 0. Hope you can see that one. So our fourth polynomial is going to be 0 plus 1 times x minus 1 plus negative 1 times x minus 1 squared over 2 plus 2 over 6 times x minus 1 cubed plus negative 6 over 24 times x minus 1 to the fourth power. What do we have? We have x minus 1 minus 1/2 times x minus 1 squared plus 1/3 times x minus 1 cubed minus 1/4 times x minus 1 to the fourth power. And that's it. That is our Taylor polynomial. And we're going to go on to example 4. Okay, let's go on to example 4 here. It says use a graphing calculator to find the indicated Taylor polynomial for the function f. Graph the function and the Taylor polynomial. So it says f of x equals 1 over x squared plus 1. We're going to do it for n equals 4 and c being 0. Then we'll do it for n equals 4 and c being 1. So first of all, if we look at f prime of x, I'm not going to go through finding all the derivatives. It's just going to be negative 2x over x squared plus 1 squared. The second derivative is going to be 2 times 3x squared minus 1 over x squared plus 1 cubed. The The third derivative is negative 24x times x squared minus 1 over x squared plus 1 to the fourth power. And you can derive these by hand or use a calculator to find the derivatives. The fourth derivative is going to be 24 times 5x to the fourth minus 10x squared plus 1 over x squared plus 1 to the fifth power. Now, our original one, f of 0, is going to be 1 over 1, which is 1. That's putting 0 there. F prime at 0, this is doing for part A, is going to be negative 2 times 0 over 0 squared plus 1 squared. That's just 0. Our second derivative at 0 is going to be 2 times 3 times 0 squared minus 1 over 0 squared plus 1 cubed. And that is negative 2. Our third derivative at 0 is going to be negative 24 times 0 times 0 squared plus 1 over 0 squared plus 1 to the fourth power. That's just 0. And our fourth derivative at 0 is going to be 24 times 5 times 0 to the fourth minus 10 times 0 squared plus 1 over 0 squared plus 1 to the fifth power. And that's 24. So for A, we have P of 4. It's going to be 1 plus 0 times x plus negative 2 times x squared plus 0 times x cubed plus 24, I forgot my over 2 factorial and over 3 factorial, 24 times x to the fourth over 4 factorial. So P4 is going to be 1 minus x squared plus x to the fourth, because 4 factorial is 24. Now, for part B, f of 1 is going to be 1/2. F prime of 1 is going to be negative 2/4, which is negative 1/2. F double prime of 1 is going to be 4/8, which is 1/2. F triple prime of 1 is going to be negative 24 times 0 over some stuff. That's just going to be 0. And the fourth derivative at 1 is going to be 24 times 5 minus 10 plus 1 over 32. That's negative 96 over 32, which is negative 3. So I'm going to put it down here across the bottom for part B, P4, and you can see it on the notes here at the bottom. P4 of x is 1/2 plus negative 1/2 times x minus 1 plus 1/2 times x minus 1 squared over 2 factorial plus 0 times x minus 1 cubed over 3 factorial minus 3 times x minus 1 to the fourth power over 4 factorial. So our P4 for part B is, to summarize it, 1/2 minus x minus 1 over 2 plus x minus 1 over 4, and this part's squared, then minus x minus 1 to the fourth power over 8. And that's it for example 4. So feel free to pause that if you'd like. I'm going to go on to example 5 here. And I'm going to clear the board. I just lost my microphone. Sorry about that, folks. Testing, testing. Make sure that's working still. Testing, yep, looks like it's fine. Okay, on example 5, I'm not having success with technology today. It says use the Maclaurin polynomials P1 of x, P3 of x, and P5 of x for f of x equals sine x to complete the table. Okay, so let's just go through here. Use a graphing utility to, we're not going to graph it. Okay, this is P3 and P5. So our f of x would be sine x. And f of 0 is sine 0, which is 0. F prime of x is cosine x. F prime of 0 is cosine 0, which is 1. F double prime of x is negative sine x. F double prime of 0 is negative sine 0, which is 0. F triple prime of x is negative cosine x. F triple prime of 0 is negative cosine of 0, which is negative 1. And the fourth derivative of f of x is going to be positive sine of 0. Sine of x, excuse me. F triple prime, or fourth derivative, at 0 is going to be sine of 0, which is 0. And the fifth derivative of x, of f of x, is going to be cosine of x. The fifth derivative at 0 is going to be 1. Cosine of 0 is 1. So our P1 of x is going to be just 0 plus 1 times x, which is x. P2 of x, P3 of x, I should say, it's going to be 0 plus 1 times x plus 0 times x squared over 2 factorial plus negative 1 times x cubed over 3 factorial. So our P3 of x is going to be x minus x cubed over 6. And P5 of x is going to be 0 for the first part, plus 1 times x plus 0 times x squared over 2 factorial plus negative 1 times x cubed over 3 factorial plus 0 times x to the fourth over 4 factorial plus 1 times x to the fifth over 5 factorial. So our P5 of x is going to be x minus x cubed over 6 plus x to the fifth over 120. So I have in the table the values for sine of 0, 0.25, 0.5, 0.75, and 1, and these are all in radians. So let's try plugging in these different values into these P1, P3, and P5, and we'll see what we come up with. So for 1, we would have 0 here, 0.25, 0.5, 0.75, and 1. Because that's just x. P3, which is going to be x minus x cubed over 6, is going to be 0. 0.2474, that's pretty close. Look at that. I mean, those are right on for 4 decimal places. Then 0.4792. Getting a little bit off, but it's still pretty close. It's still pretty close. 0.6797, so we're getting further off, as you might expect. And then 0.8333. But not a bad approximation. And P5, 0 of course, 0.2474, 0.4794, so this is still right on. And at 0.75 we're at 0.6817, so getting a little bit off, but it's still really close. And at 1 it's 0.8417, so it's still very close. Still a very close result. So C says describe the change in accuracy of a polynomial approximation as the distance from the point where the polynomial is centered increases. So these are all centered at 0, so they're right on at 0, and they become less accurate. So as the distance increases, the polynomial approximation is less accurate. I forgot my shun is less accurate. Okay, that'll do it for example 5. I want to go on and hit example 6 here before we can end. So feel free to pause this. Approximate the function at the given value of x using the polynomial f of x equals x squared e to the x and n equals 4 using the Maclaurin. Okay. So f prime of x is going to be 2x e to the negative x minus x squared e to the negative x, which is 2x minus x squared e to the negative x. And it says at the Maclaurin, so that means our c equals 0. So I'll look at our f of 0 is going to be 0 squared e to the 0, which is just 0. F prime of x, f prime of 0, excuse me, is going to be 0 e to the negative x. That's just going to be 0. There's 0, 0 there. F double prime of x is x squared minus 4x plus 2 e to the negative x. And f double prime at 0 is just going to end up being 0 squared minus 4 times 0 plus 2 e to the negative 0. It should have been 0. And that's going to be 2. The third derivative of f of x is going to be negative x squared plus 6x minus 6 e to the negative x. So the third derivative at 0 is going to be negative 0 squared plus 6 times 0 minus 6 e to the negative 0, which is negative 6. And the fourth derivative of f of x is going to be x squared minus 8x plus 12 times e to the negative x. So our fourth derivative at 0 is going to be 0 squared minus 8 times 0 plus 12 e to the negative 0, and that's going to give us just 12. So our P4 is going to be 0 plus 0 times x plus 2 times x squared over 2 factorial plus negative 6 times x cubed over 3 factorial plus 12 times x to the 4th over 4 factorial. So our P4 is going to be x squared minus x cubed plus x to the 4th over 2. And that'll do it for this section. Oh, there is one thing at the bottom I wanted to address. Is the remainder theorem for Taylor polynomials. So if you want to pause this, feel free to pause this, and you can write this down. It's also in the notes that you can get online. Down here at the bottom, it says the remainder of a Taylor polynomial is r sub n of x equals the n plus first derivative of f at, the z is correct, at z over n plus 1 times x minus c to the n plus 1, where z is a number between x and c. Okay, and that's it for 9.7. Okay, send me your questions and we'll meet online. Thank you. Bye.